Hello everyone, my name is Nikon Sondagar and I am from India. Completed MTech in Civil Engineering and specialization in Structural Engineering. So today is our topic about ductile design and the detailing of reinforced concrete structures subjected to seismic force. This is a code of practice. So today I want to discuss few points regarding IS 13920-2016. So stay with me and watch the full video. Why we do ductile detailing? Here is the because we give the ductile detailing to resist lateral load effect of earthquake shaking. So if we are ductile detailing, then it will be resist earthquake shaking. How we done? So we provide adequate stiffness, then adequate strength and ductility to resist the earthquake shaking without collapse. Here are zone criteria. Ductile detailing is almost done for zone 3, zone 4 and zone 5. This is optional. If we want to do for the zone 2, we can do it for more safety purpose. These are few terminologies. This is a beam. Beam is a member of moment resisting frame with they absorb wall load and shearing action. This is the boundary elements. That means this is the corner of the boundary in which boundary element is strengthening by longitudinal and transfer reinforcement. So we provide both direction reinforcement for boundary elements and the thickness will same as the cross section. Column is also moment resisting frame. They can absorb axial load, flexural and shearing action. Concrete cover. It is a concrete which is not confined by a transverse reinforcement. That means the reinforcement is not provided in this particular direction. This is a transverse reinforcement. Transverse reinforcement is a continuous bar with 135-degree hook at the end, and the hook length is 6 times diameter but not less than 65 mm. This is the hook criteria, and this is a gravity column. Gravity column is a not for the lateral load resisting system. This is only for axial force, shear force and bending moment. This is a lateral force resisting system. It is the part of the structure system that only resist force induced due to earthquake. This is the lateral force, that means horizontal force. So it will be absorb the earthquake, resist earthquake force. This is a moment resisting frame. Moment resisting is a three-dimensional structure in which they are interconnected members by column and beam. With the and in the moment resisting frame, the load does not resist by structural wall. The next, spatial moment resisting frame. This is a special type of resisting frame system and they have more ductility, so we can analyze in next part. This is the ordinate moment resisting frame. This is a normal building. In this building we do not provide any kind of ductile detailing for earthquake resistant structure. This is a link. Link is a single bar and the same 135-degree hook, and the hook length is 6 times diameter but not less than 65 mm, and confining in the section they provided in a particular section. They give additionally ductility and stiffness. Shear wall. Shear wall is a vertical member, so that primary design for the resistance, lateral force effect, axial load, shear force and bending moment in its oven plane. Spatial shear wall. This is the three types of shear wall I will discuss in the spatial shear wall section. So this is the general specification. Construction of the any building which is as per the IS 456, and minimum grade of earthquake resistant building is M20, but we use M25 for building. And if the height of the building is 15 meter in the seismic zone, we have to provide additionally ductility for zone 3, zone 4 and zone 5, and but not less than the requirement by IS 456 based on exposure condition. Exposure condition is given in IS 456 table number 18. This is already done. The next is a steel reinforcement criteria. Minimum steel Fe415 is used, or if you want to use Fe250, you have to read the conforming to IS 1786. Fe500 and Fe550, the elongation is 14.5% of this 2 bar and conforming as per the IS 1786. This is the actual 0.2% proof stress. Proof stress is nothing, is the yield stress, which is equal to 0.2% of the proof stress. Proof stress is also called as a plastic stress, and these are the ratio. Actual ultimate strength to the actual is 0.2%. Proof stress shall be at least 1.15. In the RC frame building, lintel is not added into the column. So you know the lintel does not enter into the column, because to avoid short column effect. If we want to integrate it, that means lintel beam is entering into the column, we have to include in the analysis model. Similarly, plinth beam, staircase and slab included in column, so we have to analysis this in the model section while we are doing analysis and design of your building. This section is given for the moment resisting frame building, in which in the earthquake resistance system, irregularity or any kind of irregularity will be ignored. Do not add any kind of irregularity. And a floating column and floating column is added in this portion, and setback column also perform poorly, so we no need to add any kind of floating column, setback column. If we require any kind of irregularities, and it is considered as a non-linear analysis, that means response spectrum analysis and time history analysis, and it will be resist earthquake force. Beam is provided to resist earthquake induced effect, in which this is axial compressive stress. This is the due to the axial compressive stress, the beam will get more bending moment and shear force. So this is the very important point, axial compressive stress, and the value does not exceed 0.08 FCK. If the greater than 0.08, so we designing as per the requirement of 7. We will discuss 7 in next slide. And for the ductile detailing, beam width to depth ratio is greater than 0.3. Minimum width of the beam is 200 mm, and depth of the beam is 1/4 of its clear span. So these are the beam criteria. Width of beam shall not exceed the width of supporting member, that means column, plus distance on either side of supporting member equal to smaller. These are two criteria, width of supporting member, and second is 0.70 times width of supporting member. These are the two criteria. 0.75, this is 0.75 C1. For the transverse reinforcement, width of the beam that exceed width of the column C2 shall be provided as shown in figure. We can see this sketch already. These are the longitudinal reinforcement. Longitudinal reinforcement, that means horizontal bar, is provided in beam section, and the minimum diameter is 12 mm, which is provided in top and bottom face. And for the beam steel ratio, minimum is calculated by this equation, and the maximum is 0.025. These are the very most important. What they say, we provided longitudinal steel on bottom face of beam framing into column. That means at the junction, provided the longitudinal steel shall be at least half of the steel on its top. That means we provided a top steel and 50% provided in bottom part. For the exterior joint, we have to encourage the length, so it will give additional safety. This is the next point, longitudinal steel in a beam at any section, top or bottom face. That means this is a longitudinal steel beam at any section, that means anywhere in the top and bottom part, have at least minimum 1/4 of the steel provided at top face of beam at the face of the column. That means if we provide any kind of column here, at the column the steel provided, and here is the 1/4 of the steel provided corner part. This is telling that point. At the exterior joint, bottom bar of the beam shall be encouraged into the face of the column, so it will give the additional safety. These are the anchorage length. These are the anchorage length. So it will transfer the stresses from slab or beam to the column. These are the splicing of longitudinal bar. That means another kind of ring, we call them ring. This is the left slice. When adopted, closely linked shall be provided over the entire length. That means we provided close space of the left slice. What are the criteria? The spacing of the left slice should not greater than 150. That means this spacing should not greater than 150, and the left length shall not be less than development length of the largest longitudinal reinforcement in tension. That means overlap length should not greater than sorry, should not be less than development length. Left slices criteria will given here. First is with left slices should not provided where within a joint. That means at the joint we are not providing left slices. Second, at 2D from the face of the column. These are 2D, and these we cannot provide left slices in this part, and up to this is a 2D. 2D is the effective depth, so we do not provided left slices until this portion. So after this, these are the area where we provided left slices. So the next point is not more than 50% of the area of the steel bar on either top or bottom face shall be spliced. That means if you are providing two numbers of bar here and two numbers of bar here, so at one section only 50% of the total area will be splices. That means we can maximum two reinforcement is of splices here. We do not do for this two, and the next part we do these two. Mechanical coupler. Mechanical coupler is only used when continuous bar is provided and span is larger, and the mechanical splices is provided if we are not providing mechanical couplers. It is a new generation. It is only useful for the diameter of 32 and greater than size. For 25 or 20 mm we have to mechanically, we can also do mechanical splices for the strengthening purpose. So mechanical splicing, if we are doing, this is capable of developing tensile strength of splices bar that is permitted within a distance equal to 2 times the depth of the member. That means this mechanical splices specified our tensile strength, and length of the splices is 2 times its depth of the member. 2 times depth of the member. And the spacing between longitudinal bar shall be based also on the outer size of couple to allow easy flow of concrete. If we are providing welded splices, but when the welded splices shall not be used in beam for a distance equal to 2 times the depth of the member from the member face or in anywhere. That means if we are doing welded splices, it is not applicable for the beam where the depth of the beam we can do 2 times the depth of the member should not allow for the welded splices in beam. These are the transverse reinforcement. Only vertical links shall be used in beam. That means for transverse reinforcement we are using vertical links. That means these are vertical links. For the normal practice, link made up with single bent up bar. That means only single bar is used. We cannot overlapping for link, but it may be made for 2 bar also. We can also do for 2 bar. First of all, this is a U link with 135-degree hook and extension diameter is 6 times diameter, and the length should not be less than 65 mm. That means these are the single reinforcement, so do not overlap anywhere, and these are the 135-degree hook at the both side, and minimum dimension is 60, and but should not be less than 65 mm, but not less than 60 mm at each end, embedded in core concrete and a cross tie. We can also provide cross tie. First of all, we have to provide the U stirrups and then cross tie. We can, these you can see, these are the one stirrups, and these are the one left slice. Sorry, cross tie. The hook of the link and the cross tie shall engage around periphery longitudinal bar. That means link is provided around periphery of the reinforcement. Crossing engaging the same longitudinal bars shall have their 90-degree hooks at opposite side of the beam. That means this hook is opposite side of the beam. If one time is here, then second time is there here. We have to provide alternative hook. These are the minimum and the minimum diameter of the link shall be, that means minimum 8 mm ring is used. Shear force capacity of beam shall be more than, that means shear force capacity of the beam is more than first factored shear force. That means these are the requirement, and we provided greater shear reinforcement. Factor gravity shear force plus equilibrium shear force when plastic hinge form. That means these are the plastic equilibrium shear force when plastic hinge, that means plastic hinge are formed at both end. We can also say plastic hinge is equal to simply supported condition. These are not important for us. These are the reinforcement details. These are the columns, and these are the reinforcement throughout the portion, and these are the anchorage length. This is the column face, and after 50 mm we have to start to providing vertical links. These are the 2 times depth of the beam. After this we have to start for the left slices. These are the close spacing of link. Spacing of link over a length is 2d at either end of the beam shall not exceed d by 4. That means link spacing shall not exceed d by 4. That means total depth by 4, and 8 times the diameter of minimum bar. This is the second criteria, 8 times diameter of bar, and third is a 100 mm. These are the close spacing of link criteria. This is a d by 4, 8 times minimum diameter and 100 mm. These are the close spacing, and from this spacing of the stirrups or vertical links is increased. You can see easily here. The up to this point the spacing is less, and after this spacing is increased. And the first link is 50 mm from the joint. We already discussed. This point is already discussed. The next is columns and inclined member. For the column and for the inclined member, we have to provide earthquake resisting system. For this, factored axial compression due to the gravity and earthquake should not exceed 0.08 FCK. That means axial compressive stress generated in column should not exceed 0.08 FCK. And if we are doing a load combination, the maximum axial stress is 0.40 FCK. For various shape of column other than the rectangular and circular, because circular and rectangular we do not need to providing ductile detailing. For the T and X shape, specially designing and detailing should be provided for the lateral load resisting system. Minimum dimension of the column should not be less than, these are the minimum dimension criteria: 20 times diameter of the largest diameter longitudinal reinforcement bar, and second is 300 mm. These are the minimum dimension of column: 20 times largest diameter and 300 mm. These are the cross section aspect ratio. For the smallest diameter to the largest diameter of the cross section of the member shall not less than 0.45, and for the RC building the cross section ratio is 0.4 shall be designing. These are the strengthening of the beam and column at a joint. We have to require beam column joint is stronger, so we have to designing for the moment resisting frame, and the sum of the nominal designing strength for the column is at least 1.4 times sum of the nominal designing strength for beam. Why we do this? For the strong column and weak beam condition, we have to strengthening column 1.4 times greater than beam. In the event of beam column joint not confining to the above, the column at the joint shall be considering to gravity column. If we are not satisfied this criteria, so the then column is considered as a gravity column, and we do not designing for the lateral load resisting system. And then next is a design moment of resistance of beam shall be done using limit straight method, limit state design, and using IS 456 method. The design moment of resisting of column shall be estimated for the case of where we have to and done first of all for the zero axial force on the design of PM interaction design. These are the step is given in a while you are designing for the using state flow and ETFs. You have to check for the positive and negative direction of the stacking of the beam. Further, for the check design moment of resistance is a beam joint check also provided, and this is also do for the column also. Then next is the longitudinal reinforcement. Minimum reinforcement for the circular column is 6 bars and for the square column is 4 bars. These are the left splicing of longitudinal bar. These are the left slice. When adopted, close ring shall be provided over the entire length over which the longitudinal bar are splices, and the spacing of the link shall not exceeding 100 mm. So the minimum spacing, maximum spacing is 100 mm, and the lap length should not be less than the development length. Lap length is equal to the development length, and the lap slices shall be provided only in the center half of the clear column height, and lap slices do not provided it within joint and 2 times 2d from the face of the beam. We have to providing 2d the distance from the face of the beam, and at each time 50% of the steel bar is spliced. We don't need to do 100% area splices, and for the splices greater than 32 mm diameter bar, mechanically splices shall be adopted. We can also use mechanically coupler. Mechanically coupler classification is provided in IS 16172. If we are not using mechanical coupler, we want to use mechanically splicer that gives a specific tensile strength. So we meet our requirement, and the length of the splices is 2 times the depth of the member. These are the welded splices criteria. Welded splices is not used in column for a distance equal to 2 times the depth of the member, because for the column it is very less. So always we are using mechanically couplers for the columns, and minimum 50% of the area is spliced at a single time. If any column is extended 100 mm for the architectural requirement, like this 100 mm, so we have to provide additionally reinforcement like this. Additionally stirrups is provided here, and these are the second criteria. This is main stirrups, and this is additional stirrups provided. You can see these are the main stirrups, then these are 2 additional stirrups provided. For the transfer reinforcement contain consistency of 2 loops. We provide spiral or circular links, and second is rectangular links. For the both case, 135-degree hook is compulsory required, and the hook length is 6 times diameter, but not less than 65 mm. When rectangular links are provided, if we provided rectangular links, minimum diameter is 8 mm. If diameter is equal to or greater than 32 mm, we provided 10 mm stirrups diameter. Maximum spacing of the link is 300 mm. We should not provide it greater than 300 link spacing. We can also provide a cross tie if the length of any side of the link exceeded 300 mm. We only provided cross tie if the one dimension length is exceeding 300 mm. These are the 3 criteria. I will discuss in directly sketch. These are the first criteria. If the dimension is less than 300 mm, we have to provide only one links like this, and the dimension hook length is 6 times depth, which is equal to greater than 65 mm. These are the second criteria. If this dimension is greater than 300 mm, we have to provide additionally cross tie. You can see additionally cross tie is provided. If the length is less than, we have to provide only one ring. We do not provided any cross tie here. You can see these are the single ring and these are the additional cross tie provided. If this dimension is greater than 300 mm, then what we are doing, we have to provided these are the main ring. These are the by mistake dimension is greater than 300 mm. So what we do, one link, one cross tie here and two cross tie here. These are like this. You can see these are the this one and these two cross tie, and this is the main ring. This is this is the criteria, and this is the, if the dimension is greater than 300, these are also greater than 300, then we have to provide this. And designing shear force in column, factored shear demanding as per linear structure analysis. We are doing calculating shear force as per the linear structural analysis. If for the calculated for the factored equilibrium shear force is done when only plastic hinges are formed at the both end. These are the condition. If plastic is formed, then we have to equilibrium shear force calculated. These are the specially confining reinforcement. This requirement is met at a beam column junction. Otherwise, this criteria is required for the largening amount of transverse reinforcement is required. So avoid the larger reinforcement required, we provided beam column junction with special confining reinforcement. This is done for the flexural yielding in the beam during the strong earthquake shaking, and in column when the shaking intensity is exceeding intensity earthquake. This is L0 length. I will show you. These are the L0 length from the face of column. These are the L0, these are the L0, which is equal to or greater than uh, which is equal to or greater than the overlapping length. Larger lateral L0 is larger lateral dimensions of the member. These are the first criteria. Second is 1/6 of the clear span, and third is 450. This is the L0. This criteria, first of all, larger lateral dimension. Second is 1/6 of the span, and third is 450 mm. Spacing criteria is 1/4 of the minimum dimension of the minimum dimension of the beam or column. Then second is 6 times smallest diameter, and third is 100 mm. The spacing should not greater than this. That means maximum spacing is 100 mm. These are the reinforcement calculation. This is the L0 length. This is the h by 4 dimension, and you can call as a spatially confining reinforcement. These are the confining joint. with beam framing into the all fourth side. These are the next one important point. When a column is terminated into the foundation footing, what we have to do? We have to extend stirrup from footing top level to 300 mm below into the footing. You can see we have to extend it from this to this spot 300 mm. We do specially confining reinforcement for column footing. We are doing specially confining reinforcement over the full height of the column when the variation of stiffness is happening throughout the height. These are only due for the abnormal changes in the cross section size. If the sizes varies, we have to do the confining over the total dimension of the column or beam. Beam framing into the column RC wall or masonry wall adjoining column and extending only for partially column heights. Column supporting reaction from discontinuous members such as wall shall be provided for the specially confined reinforcement over their full height. If the wall is here, so you have to specially confine mean reinforcement in the overall the section. Beam column joint of the moment resisting frame, these are unimportant. These are the very most important. Spatially shear wall for the general requirement of the section apply to spatially shear wall that are the part of lateral load resisting system of the earthquake resisting RC building. This is shear wall is applicable for RC building. Then they take the maximum earthquake resistance when the earthquake load is applied. What are the criteria for the shear wall? Minimum thickness is 150 mm. The and second is 300 mm for building with coupled shear wall. If you are providing minimum 150 mm and then second is 300 mm for coupled shear wall, and minimum thickness is also provided for the fire resistance safety purpose as per the IS 456. Length to length of the wall to its thickness ratio is minimum 4 we required. Spatial shear wall shall be classified. There are three types of spatial shear wall: squat, intermediate, or slender, depending on the height of the structure. If height to length is less than 1 is called squat wall. If the height to length is greater than 1 or less than 2, that means we call intermediate walls. And if the height to length ratio is greater than 2 is called slender wall. Spatial shear wall should be provided uniformly spaced reinforcement in its cross section along the vertical and horizontal direction. That means in the case of special shear wall, reinforcement is provided in vertically and horizontal direction uniformly. The minimum area calculated as per the table 1. Reinforcement bars should be provided in two curtails within the cross section of the wall, which each curtails have bar running along vertical and horizontal direction. These are the factor shear stress demand in the wall which is exceeding 0.25 root FCK and the wall thickness is 200 mm. And largest diameter of the longitudinal steel bar used in specialing shear wall should not exceed 1/10 of the thickness of the wall, and the maximum spacing of vertical and horizontal reinforcement is 1/5 of the horizontal length of wall, and second 3 times the thickness of the web, and third is a 450 mm, and the spacing should not exceeding these three value. Spatially shear walls shall be found on a properly designing foundation and shall not be discontinued to rest of the beam column or inclined member. These are the design shear force criteria. We have to calculate the nominal shear stress as per the equation given. Tau V is V upon thickness of web and dw depth of the whole section. And this is the equation of the tau C given in IS 456 table number 19. These are the few criteria. When nominal shear stress demand tau V on tau, this is depend on the tau V value. If the tau V value is more than the tau C max, then we have to do, we have to redesign the structure, because generally tau V is always less than tau C. If we are doing redesign, then we get tau V is less than tau C. We have to add in more reinforcement for this case. And second, design shear strength, design horizontal shear reinforcement shall be provided. We can provide additional shear reinforcement to achieve our the tau C designed shear strength of the concrete area. Next topic is considering next part. Thank you for the watching. Like my video, share with your friends, and stay with me. I will provide more IS code videos